Hello everybody, sorry for the slightly late start today. Just been having some strange technical issues with the peripheral voltage settings. There was some unexpected voltage drop and the peripherals were sending lots of interference to the computer or something. Not quite sure what I did to fix it, but it actually seems like it's going okay now. You'll notice it if the screen starts flickering dramatically, but currently it doesn't appear to be doing so. So, welcome. Sorry for the delay. Another double header session this afternoon talking about what is already a record-breaking heat wave in parts of the Southwest in California today, and that's going to continue for the rest of the week and perhaps beyond in some places. And then also talking about the still unfolding flood catastrophe in the Southern Appalachians, including western North Carolina and eastern Tennessee from the aftermath of Hurricane Helene and the predecessor rain event that came before it. One person remarking that there's an audio echo. Just want to make sure that's actually correct. No, it is coming through the correct speaker here, so for now, unless someone else comments about that, I'm gonna let it go. So, as I mentioned, today will be a bit of a doubleheader session. I want to start by talking about the heat wave in California and the Southwest, because here we are again, essentially. And then the other reality is that the southeastern part of the country is still reeling from what is probably going to turn out to be one of the worst flood events in modern American history. In fact, I think it's pretty clear at this point that it already is. So I want to reflect a little bit on the event itself, its aftermath, because I think that story is still largely untold. We often hear less about the very worst disasters because when it gets bad enough, it's actually quite difficult to get the word out because telecommunications are down, and that does appear to be how bad things are in Southern Appalachia at the moment. And since this occurred Thursday and Friday of last week now. So I just wanted to remind folks that the channel is sponsored partially by Reask, a climate tech company that's helping folks rethink their extreme weather risk in a warming climate. So as always, grateful for that sponsorship from Reask. I think a lot of folks are probably not surprised to find that some very hot temperatures have reached the coast in California in early October. That in itself is not particularly unusual. In fact, late September and early October are historically the very hottest weeks of the entire calendar year in places like downtown San Francisco and the coolest parts of the North Coast. So this is the time of year when the fog historically goes away, finally. There's less cold water upwelling near the coast off the Farallones, and when heat waves inland actually can make it to the coast because there is at least a little bit of wind blowing from land to sea. So weak offshore flow rather than the more typical onshore flow that you'd see with a sea breeze, for example. So there's not much fog. There's also not much of a sea breeze, at least over areas more than a few miles inland from the coast. So this is one of those heat waves, and there are parts of the city of San Francisco proper today that have reached over 100 degrees. So that's newsworthy anytime it happens. In fact, it hasn't happened since 2022, so it's been a couple years. So in that sense, the fact that we're seeing a rather intense coastal heat wave this time of year is not that unusual, but once again, it's the magnitude that counts and the breadth and duration that also count. And in all of those respects, this is yet another remarkable, even record-breaking event. So not every place, of course, is going to see new records, but some places have already, as of today, set brand new October monthly records. It does help a little bit that this heat wave is occurring on October 1st, which, as you'd expect, the month of October does get progressively cooler throughout the month, so it is a little bit easier to set those monthly records at the beginning of the month versus the end of the month. But for perspective, some of these temperatures we're seeing in the Southwest today would also have been September monthly records, and that is even more notable. So we'll dig into that in just a moment. So the immediate coast in some areas is actually pretty hot today, and that includes places like San Francisco. Inland areas, of course, are also hot, but this is one of those interesting patterns where some of the very hottest temperatures occur up in the coastal hills of Northern California, not necessarily in the Central Valley, where it is hot in the 90s and low hundreds, but nothing particularly dramatic. It's a lot more unusual to see 100 degrees in San Francisco, for example, than it is in Fresno. But in the coastal hills, they're a little bit higher up in this anomalously warm air mass. In fact, this air mass is one of the hottest October air masses ever observed over Northern California. Part of this is because the high pressure zone off the coast of California right now is at its strongest level that we've ever seen this time of year being in late September or early October. So not just confining it to the calendar date, but it is fairly significant that this is the strongest offshore 500 millibar ridge we've seen in this part of the world in recorded history within this multi-week moving window. So that's notable unto itself, and accordingly the air mass is really warm. That is another reason why the heat is making it all the way to the coast today, which is because there is downward motion in the atmosphere that's suppressing the marine layer that might otherwise try to form, but it also means that the air itself is warming adiabatically or compressionally. Think about how a bicycle pump might heat up if you pump it vigorously for a while. The container of that compressed air gets pretty hot because the air inside is heating as it gets compressed over time. The atmosphere is doing that, perhaps not quite as rapidly or dramatically as a bicycle pump, but it's the same process at play. That is one of the reasons why you can get such extreme heat with under heat domes, and the reason why they're essentially referred to that way is because of this dome-like effect where you put a lid on the atmosphere and then you kind of gradually compress it downward. So of course, upward motion favorable for the formation of clouds, storms, and precipitation. Downward motion very unfavorable for the formation of clouds, generally speaking, except for possibly fog near the surface. But if it's not particularly saturated, and you're not going to get fog, what you end up getting is air that considerably warms as you get closer to the surface and as that downward motion in the atmosphere or subsidence occurs. So we're seeing that now. This is not just a typical October coastal heat wave, though. There is also really anomalously hot temperatures inland. In fact, Palm Springs today, I believe, in the last hour reported a new October monthly record high temperature. In fact, some initial data, and I'd like to get this right, so let me, this is preliminary, but I'm just curious, well, I think folks will be curious to hear it. Palm Springs in the last hour hit 117 degrees, which of course is very hot at any time of year. Palm Springs being a very hot place, but even then, Palm Springs in October has never been above 116 degrees previously, so this breaks the 1980 record for the month of October. It also apparently ties the record for the hottest temperature ever observed so late in the year anywhere in North America. So again, currently, as we speak, Palm Springs is as hot or perhaps hotter than any location in North America has been in recorded history this late in the calendar year. So that is not a subtle or cherry-picked record. That's quite a significant one in broader context. Phoenix as well, if we go into Arizona, has exceeded 110 degrees today. That has never happened before in the month of October. It has, of course, happened many times in the peak summer months, but October is getting pretty late in the year for that, even in Phoenix. It's also the 67th time this year that Phoenix has exceeded 110 degrees, which is pretty incredible. For perspective, the latest date that Phoenix had ever seen 110 degree reading previously was September 19th back in 2010. So this is almost a full 2 weeks later. So that's another notable record. And it may be even hotter in both of these places tomorrow or on Thursday. So, this is not a short duration heat wave by any means. In fact, the last week across much of the north central U.S., so talking about the northern Great Plains, the Great Lakes region, as well as the Rocky Mountain Front Range, have been the warmest end to September and start to October on record. By a pretty significant margin, up at 6,000 or 7,000 feet up in the Rockies right now. It's in the 80s in October, and that is not typical One day of that perhaps might happen every once in a while, but it's been like that every day recently. So this is essentially feels like summer, and folks have been joking that it's currently October, and literally in many parts of the West, temperatures are in fact much closer to August values than October values, and yet here we are. It's the same month as Halloween, and we're still talking about midsummer like peak heat. So obviously it's the 1st of October, and so we are still early in the month, but looking ahead, quite frankly, there's a pretty strong signal that this heat wave is certainly going to continue for the rest of the week, peaking today or tomorrow along the California coast, but then later in the week, even into the weekend, as we go inland into southeastern California, the deserts, the mountains, and then even into early next week in some parts of the interior West. There will probably be a cool down at some point in this window in different places, but then it looks like it's pretty likely to heat back up again right after that, and there is not right now any obvious sustained relief in sight in terms of significant widespread precipitation or near or below average temperatures. It does look drier than average and hotter than average across almost all of the West for the foreseeable future, 10 to 14 plus days out. The exception might be the Pacific Northwest. This won't necessarily be true up in Washington State and maybe in northwestern Oregon, where it could rain and it won't be as warm. But everywhere else, this heat and anomalous dryness looks like it's going to continue. And by the way, all of this is quite consistent with what the seasonal outlook from the multi-model ensembles had suggested that the fall would look like overall. So even though we had that cool and damp interlude in mid-September, that is definitely in the rearview window. In fact, we're even seeing some fires that ignited in Southern California in early September during that record-breaking heat wave, and then looked like they were mostly under control during that mid-September drizzle, even some, let's call it mixed frozen precipitation period at the highest elevation of those fires in the San Bernardino County and Los Angeles County mountains, where there was certainly some frozen precipitation. Whether it was graupel or hail or snow is the subject of some rather amusing online debate. But the point was, there was precipitation and it was frozen in the fire zone. And so that's pretty favorable weather, as you might expect, for getting under control. And yet, the line fire this week has sort of exploded back to life, made major runs, jumped a couple of roads in very steep terrain, and there are now reissued evacuation orders and warnings in effect. So we kind of have jumped back to where we were in early September in terms of fuel moistures in a lot of places, in terms of wildfire risk. So there aren't a great number of large active fires in California right now. The one big exception actually being the line fire, which has been active now for almost a full month. But there are a bunch of new smaller fires popping up. None of them, at least last time I checked today, look particularly problematic yet. But if you look at the satellite imagery, and I'll show this in a moment, there are still a fair number of significant active fires throughout the West, including the interior West in places like Oregon and Idaho and Wyoming and Montana. And that's starting to get fairly unusual as we go further into October, because the fire season along the California coast, especially central and southern coast of California, it's a late season. It's lagged relative to the rest of the core western U.S. So fire season in the core western U.S. usually peaks for the most part in summer, but locally in early autumn in places like coastal Southern California or even up to the Bay Area, where you can get those autumn heat waves plus those offshore Santa Ana or Diablo, or up in far northern California, northeastern California, they're known as the Jarbo Gap winds. And you can occasionally even get those kind of east wind events up in Oregon in the Cascades into September or maybe early October, but you're really pushing it up there by October. Likewise, in the Rockies, usually it's chilly with at least a first snowfall or two as you get toward early to mid-October, and yet right now, as I mentioned, it still feels summer-like up there. There's fall color up at 8,000 feet in the Rockies, but it sure doesn't feel like fall temperature-wise right now. It's really warm. So what this means is that fire season is continuing, and if there are any major wind events across the West in the coming days or weeks, until the first significant rain or snow falls and we don't continue to see these record-breaking heat waves, fire season is going to continue in some parts of the interior West much longer than it usually does. So not only will it continue in California, which is somewhat less unusual, but it could be pretty active given how hot it is now, how much grass and brush fuel loading, as I mentioned, there was from the abundant rains earlier this year and last year, especially in Southern California, with the legacy of record-breaking heat in most of California back in July, and then specifically in Southern California at the beginning of September, and then perhaps again now. That sets us up for a pretty hairy situation, if you will, if and when we get those major offshore wind events. Not seeing any major offshore wind events currently in the forecast, which is good, but there are still red flag warnings in effect for parts of California and other parts of the West because of non-extreme wind conditions, but combined with extremely high and even record-breaking temperatures and very dry and abundant fuels. So there will be an increased level of wildfire activity. I wish it were wildflowers, wrong time of the year for that. But if and when there are major wind events before the next major precipitation event, then there will likely be periods of extreme fire risk. Now again, right in this moment, despite the red flag warnings, I don't think there's any truly extreme fire risk anywhere in the West at the moment, but there is certainly elevated or even locally critical fire risk. But if and when we see those big wind events, and it could be an offshore wind event, by the way, or a westerly wind event somewhere across the interior. So either the Sierra Crest, those westerly wind events can sometimes be a problem if fires break out, and also across the Great Basin, the Rockies, and even along the Front Range on the eastern slopes of the Rockies. Those downslope winds are actually west to east winds, and they do start to pick up usually in the fall. So one challenge with all of this is that California is at least somewhat used to seeing fires well into the autumn, and so CAL FIRE is, of course, a year-round wildland fire agency that's equipped to deal with that, but the Forest Service is generally not, and there are on a lot of federal lands, a lot of the wildland firefighters who are primarily available during the peak of fire season, so from late spring to early fall. These are seasonal jobs for the most part, and those firefighters start to get let go. I believe it is starting now in October. So if we see a really late fire season, that could actually start to become a problem because of personnel and resource availability, especially on federal lands. And that might compound the fact that there's already a shortage of federal Forest Service firefighters this season for a variety of reasons, one of which is that it's becoming increasingly untenable to have that as your profession because the pay is so low and the benefits so poor. Part of that is because it's not a full-time role. I think it's pretty clear that we need at least some full-time presence, partly if we want to do larger scale prescribed burning, because sometimes the best windows to do that may actually end up being in late fall or winter in some years, and it's difficult in many cases to do that because the personnel who would be available to do it at other times of year when they're busy doing other things like fighting unwanted wildfires aren't available because they're not on the pay circuit at that time of year. So this is a real sort of multiple challenges coming to head with respect to weather, climate, federal forest policy, and other things. Just thought that might be an interesting aside. But okay, I want to show some imagery. This is going to be what I do in the first part, as I mentioned, talk about the ongoing heat wave in California, and then about halfway through, maybe about 60% of the way through, so in about 15 minutes, I'll pivot to talking about the flood catastrophe in the southeastern U.S. That continues to look pretty terrible. Okay, bear with me for a moment. You'll quickly see the infinite mirror on the screen. Yes, I know, I just haven't had time to do anything to change. Okay, so what you're seeing right now, this is a cool website. Literally, the website is coolweather.com, coolwx.com. Let me refresh this to make sure it's the most recent data. None of these are official records, by the way, but this gives you a sense of places that are, as of the last hourly reporting window, experiencing record temperatures. And this is a really notable map for two reasons. One is that there are multiple places experiencing record or near record temperatures in the U.S. right now, all the way from Key West down in Florida to Houston, Texas, to Arizona, Colorado, Utah, Nevada, and California. That's a pretty broad swath in different parts of the southern tier of the U.S., But the most notable numbers are that there's actually a lot of pink dots on this map. And if you can look down in the key here, pink means tying or breaking the all-time monthly record. And so that is one. Well, seems like the image is not being shared. Apologies, folks. Technical difficulties. Let me... as I mentioned, today has not been a great day for technical issues, so let me just see if this comes up. Nope. Okay, sorry for that. I don't know why this is happening. Let me just quickly... I'll do this for now, because... Okay, now you're seeing my live stream, which is better than it was. Okay, here we go. I think this should be doing the trick now. Yeah, it actually seems like one of my USB ports in my brand, I guess it's not brand new anymore, 1-year-old MacBook seems to be broken. Lovely. Okay. So as I was saying, you can see these dots. These are the record-breaking temperatures currently across the U.S. And what I was noting were the purples. Again, I've a slip there. The pink dots, pink or purple, topic for debate in the comments section. Anyway, those are monthly records. There's a lot of places as of the last hour, as of 3 or 4 p.m. Well, I guess it's as of 3 p.m. actually. In the western U.S., southwestern U.S. in particular, that are breaking monthly records. I'm going to scroll down so we can look and see where some of these numbers are like. As I mentioned, there's the Palm Springs number, all the way up at 117. Phoenix is now up to 111. But there's just this long laundry list. I think Palm Springs is the hottest of them all, but these are all pretty impressive numbers in relative terms for where they are. In lots of states, so lots of places today breaking October monthly records, and a lot of these places will also probably see even higher temperatures at the 4 p.m. report. So they've already broken the monthly record and they're on their way up still. Numerous other locations with daily records. So, you know, this is pretty impressive. Point Reyes, notably, at least for a brief period today, reached the upper 90s, which is in some ways even harder than San Francisco reaching 100 degrees. I don't know if the official recording site in San Francisco actually reached 100 degrees today, but it certainly was over 100 in some of the neighborhoods, including up by Twin Peaks and up by McLaren Park. So definitely a hot one. The other thing I wanted to illustrate was just making sure everyone's seeing. Yep, we're all good. So here's the satellite map, and I think right now, due to the technical difficulties, I'm not going to be able to use my drawing tool since you're only seeing my browser window. I can't show multiple programs at once, so fortunately I wasn't planning on using it that much today anyway. Maybe you'll just see the cursor for today. I'll figure this out later. I'm not sure what's happening in this last frame. There are data issues actually, because a lot of the data is flowing through, or usually satellite data was flowing through the National Climate Data Center, which is located in Asheville, North Carolina, which has been not completely offline, potentially in the long term, due to the catastrophic flooding there. I'll talk about more about that in a moment, but I think a lot of people have pivoted to alternate data sources for the satellite imagery, and as you can see, there's some wonky stuff going on. But anyway, this is the actual visible imagery. Nothing too dramatic right now, except that to say that I'm actually going to freeze it on one of these better frames. Nothing too dramatic, except that normally in October there'd be a storm somewhere in the western U.S., and there just is nothing there. There's some low clouds up over coastal Washington, there's some high clouds over Montana, but otherwise, aside from a little bit of coastal stratus down by Monterey County, there's nothing. But the only thing you can see, and it's a little bit hard to see in this frame, so I'm actually going to switch over to shortwave infrared. There are wildfires. That's the one thing we do have. And this is where I would use my drawing tool, but you'll just have to use your imagination. With my cursor here, there's one significant fire in east central Oregon here, another one in southwestern Idaho, a couple of other ones up in north central Idaho, and then a really big one over in Wyoming right now. There are also fires burning in Nevada and Utah, and locally in Colorado, but for the moment they don't have much of a thermal signature. If I zoom in on Southern California, what you'll see, well, there's three interesting things I would have circled here. You can actually see the recent wildfire burn areas pretty clearly because, well, with all that black soil, the land surface got really hot. You can see this was the airport fire. You see that dark black blob. It's not active fire anymore. That fire is essentially extinguished. But the land surface is extremely hot because, as you can imagine, during a heat wave with essentially 100-degree plus weather around but black soil surface, it gets even hotter than it would have if you had chaparral and grass there. Same thing here. This is the bridge fire, also showing a thermal signature not because of flames, but because the ground is hot, because it's nice and black and charred. Line fire over here is a little more interesting. So the western side of the line fire, what you can see is it's dark because the soil's warm, but here there is actually some active fire line, and you can see that black dot on the eastern edge of the fire popping up. That is active flames. There's actually some clouds that have built up above the fire, so some pyrocumulus going up because that fire is pretty active that's hiding those flames, but this is actually still an active fire zone up by Big Bear, and there are evacuations that are back in effect there. So this is what it looks like with visible imagery. Again, you can see those clouds. There are some mountain cumulus, but there is some smoke and active fire there too. But all in all, the most dramatic thing is that there isn't anything more dramatic. There really is no precipitation right now anywhere in the west, nor any storms. Just clear skies, heat, and some scattered wildfires. Could be worse, but it sure could be better too. And then I want to show some weather model imagery. So this is the most recent European model ensemble. Again, I'm sort of using, well, actually, let me just do the daily average here. This is right now. These are the, this is right now. And you can see that it is extremely anomalously hot along the northern and central California coast, up in this region right now. It includes the Bay Area, and then again across the deserts of southeastern California and Arizona, also across Wyoming, but generally much hotter than average across all of the west, with only a couple of pockets of cooler than average in adjacent regions. But look, I'm going to step forward in time. This is tomorrow. Tomorrow could be even hotter in some parts of interior northern California. Temperatures in the morning to afternoon. Sierra foothills could be extremely hot for October tomorrow. San Benito, interior Monterey County is extremely hot, along with, again, the coastal North Bay. Ukiah, up in the mid 100s to getting closer to 110 in some areas. These will be close to all-time October monthly records. Also very hot in coastal Southern California, and again, an extreme heat wave across the Great Plains. We're talking about temperatures that are 20 plus degrees Fahrenheit above average. This is late Wednesday. These are some bright pinks. And again, these are in units of degrees Celsius anomalies, so multiply it by the conversion factor to Fahrenheit, 9/5 to get your Fahrenheit equivalent. These are pretty large values. We go into Thursday. No real change. It's a little cooler along the coast of the Bay Area, but this is still a major, major heat wave across essentially all of California and the Southwest. Record. We could be setting October record temperatures multiple days this week. We go into Friday, and it'll still be, again, much warmer than average across all of California, but we start to see some cooling up north and toward the Bay Area, so merely 5 or 10 degrees above average instead of 20 to 25 degrees or so. But the trade-off is that we then start to see really extreme heat across the interior west, so this axis from around Death Valley all the way up to northeastern Wyoming again. So I would expect this wildfire situation along that swath to get pretty serious. We do see a trough come through over the weekend, as I mentioned. Some cooler weather, especially up in the Pacific Northwest, with some relief in California, but again, mostly remaining warmer than average. That's not really much of a break. I mean, look at all that red and pink as we go from Saturday back towards Sunday. And then the ridge rebuilds. As we get towards Sunday and Monday, it looks like it could actually get hotter again and approach levels we saw this week. Again, maybe less so in the Bay Area and the North Coast, but we're talking about Southern California, Southern Nevada, Arizona. This just looks like a major heat wave returning early next week. And the Pacific Northwest heats up somewhat too. So again, just these reds and pinks, the rule. Those are bright values. Those actually are large numbers, despite the hate mail I've received this week about using the color pink. First of all, I don't create these maps. Second of all, ... But third of all is that these values really are large. A 12 to 16 degree centigrade anomaly, which is what you're seeing on your screen, again, do your conversion to Fahrenheit, and we're talking about anomalies that are 20 to 25, or locally even higher, above average. Those are very large departures from your October normals. So yeah, it should be a striking bright color because these are literally the hottest temperatures that some of these places have ever experienced in the month of October. So yeah, it's going to be bright pink. Just continuing, I mean, again, the axis of most extreme heat next week looks like it's going to shift across the Rockies and the Front Range, but again, it remains warmer than average everywhere except for perhaps parts of the immediate California coast. And this pattern just kind of continues. I just clicking through, we're getting toward October 12th, we're 12, 13 days in the future. Not quite as extremely hot in California, but my point is, man, oh man, oh man, I'm going as far out as the model ensemble goes, and there's still a lot of red and pink on the map, even across most of California as we get into mid-October. So not really seeing, unfortunately, much likelihood of relief. Why is this if we look at the geopotential height anomalies? So here's that record-breaking ridge offshore right now that I mentioned. You see that west of California. No surprise there. But look at how this evolves. It strengthens, then it weakens, but then it kind of rebuilds inland again as we get into the weekend, into next week, and has more of a focal point across the Rockies. Some troughs try and build over the west coast, but don't succeed, and we're just kind of left under this diffuse ridging through October with above average temperatures. There could be brief interludes with precipitation, but if we look at the next 10 days, as I mentioned, western Washington will see some rain and maybe Portland. But outside of a chance of a few sprinkles along California's north coast, I'm not seeing really any chance of rain at all in the next 10 days in California. And really prospects, even as we go out toward mid-October, are pretty bleak across much of the West. Just to show this relative to average, all the yellows are places where precipitation is expected to be below average, and again, that's pretty much everywhere. There's not a lot of yellow in California because we don't usually see a whole lot of precipitation in absolute terms, even in a typical year in early October, but we certainly aren't seeing any sign of significant rain at this point. So I'll go back to this briefly to see if I can refresh it. If there's any new records coming in. So Ukiah was up at the last hour to 104, which may be breaking the monthly high temperature record already there for October up in Ukiah. And again, it might get even hotter than that. So, all right, so I'm going to stop sharing my slightly awkwardly shared screen for now. And what you'll see is I'm going to take a look at some of these questions, and then I'm going to launch in to the Hurricane Helene and flood-related portion of this conversation today. So I'm going to answer questions about the first half now, and then move on to the second piece. That's a good question. Would this heat wave have been more intense if it happened in July? Yes and no, because we probably wouldn't have seen a heat wave like this in July. It's harder to get heat waves, as I mentioned, that extend all the way to the California coast earlier in the summer because it's harder to get that offshore flow. We have that natural air conditioning provided by the marine layer in July with that coastal low clouds and fog. So we might not have seen this, that kind of coastal heat in July. But we could have seen much more extreme heat inland. And in fact, we can almost say, what would this have looked like in July? We pretty much got this heat wave in July because we had record-breaking ridge with record-breaking heat across nearly all of California in July, and that nearly all is doing a lot of work because the coastal Bay Area was not record warm. The LA or San Diego metro areas were not record warm. In fact, they remained relatively comfortable during that record-shattering heat event that occurred across about 89% of the land area of California, except for the very populated 10% along the immediate coast, where, of course, most everybody who's listening to this conversation lives. So that is sort of what it would have looked like in July. It actually would have been a much more extreme heat event overall, but probably not in San Francisco or Los Angeles. In Sacramento, Palm Springs, absolutely, and it was. Those places broke records this past July when we did have that record-breaking heat wave. So midsummer heat waves and autumn heat waves often look different. There can be less of an extreme differential between the Central Valley. Sacramento could be 99, 100 degrees during an autumn heat wave, and as is the case today, downtown San Francisco could get pretty close to 100 as well. You would very rarely see that in July because it could be 110 degrees in Sacramento, but it would be far more likely to be 60 or 65 degrees on that same day in San Francisco. So the heat wave would definitely look different, but this tends to be what a record-breaking autumn heat wave looks like. It's not record-breaking everywhere, but it's record-breaking in different places than an early summer or July heat wave typically would be. Lots of folks reporting some pretty high temperatures, except for apparently if you're on the beach in San Diego, where it's at where it's in the low 70s at Dog Beach, but 100 degrees just a bit east, which is pretty consistent with this sharp gradients we're seeing today. Thanks for the kind words about the threads. I will actually talk about those threads when we talk about Helene in a moment. So Mary asks if record-setting high pressure is to be expected with climate change, or is it just weird? This is an interesting question, and it's actually kind of, if you can turn into quite a deep philosophical one, or a research question, which is one that we have deeply engaged with in our own work. It's interesting because if you think about it, what is atmospheric pressure at its most essential level? At the surface, the atmospheric pressure is literally the force exerted by the mass of air in the column of the atmosphere right above your head all the way up to the top of the atmosphere. So whatever the pressure is where you're currently sitting watching this, there is a column of air tens of thousands of feet tall, well, really hundreds of thousands of feet tall, but almost all of the mass is in the first few 10,000 feet, pressing down on you, and that force is the air pressure. Now, obviously, from day to day, that air pressure changes. You have low pressure, you have storms, you have high pressure, you have heat waves. What that means is that there is literally more air above your head when the pressure is high, and less air above your head when the pressure is low. This is why some people actually feel it. The joke about folks with arthritis and weather changes is actually not so much of a joke. It is something that can be perceptually felt through human and animal physiology, as the research shows. And this is why you literally are shifting around the amount of mass in the air above your head with high and low pressure. But those variations in pressure are usually fairly modest. So maybe at most, in the most extreme values, maybe a 10% variation in the pressure would be the difference between one of the strongest hurricanes on Earth and one of the strongest high pressure systems on Earth. Maybe 10 to 15%, let's say. So let's be conservative and say the difference between the strongest storm on Earth, the lowest pressure observed at the surface, and the very highest pressure and high pressure system ever observed is a variation of only 15%. So all of the weather you experience is within that range. Now, you go up a mountain, and you very quickly experience a much larger pressure drop than just that 15%, because of that decay of air mass. With that, as you go up, the density of the air decreases non-linearly. So you can go up to the top of a mountain. Even here, a mile up in Boulder, we are essentially experiencing a pressure that is a surface pressure at this altitude that is lower than the lowest surface pressure ever observed anywhere on Earth at sea level. Some interesting statistics there. But the reason I mention this, really, it's a bit of a tangent, but to answer the question directly, is because there is a finite amount of air mass on Earth. For all intents and purposes, there's some atmospheric physicists who could argue about the tiny little details and hydrogen and all that and things escaping, or molecular, but anyway, interactions with photons and such. But the point is, for all intents and purposes, there's a fixed amount of mass in the Earth's atmosphere. Also, there's some variations because the amount of water vapor can vary, with precipitation and evaporation from year to year. But generally speaking, there's essentially a certain weight of that air collectively in the whole Earth's atmosphere. We're just moving it around day to day with high and low pressure. So it's essentially a zero-sum game. In other words, there's high and low pressure. That if there's high pressure in one place, there's got to be compensating low pressure somewhere else, because mass is, for the most part, mass is always conserved, but for the most part, it is a closed system, and it can't really be exchanged elsewhere. So we're just moving air around, high and low pressure. So in other words, in a warming climate, there's not any new air, really, to speak of. So we're still just moving that same mass of air around to different parts of the Earth. But might we see different patterns of high and low pressure? That is certainly possible, although it's somewhat uncertain. But the reason I'm talking about all this right now is that when we talk about ridges of high pressure, we're actually not really talking about surface high pressure. We're talking about the pressure at a particular level of the atmosphere. In particular, those maps I just showed you with the big red blob west of California, that is the pressure surface at what is known as the 500 millibar level. The 500 millibar level, the surface pressure of the Earth is just above about 1,000 millibars. So when you're at 500 millibars, that's the level of the atmosphere at which about half of the Earth's air mass is above and half of the Earth's air mass is below that level. And that value can change over time. So what's happening as the atmosphere warms due to global warming overall is that we're seeing that the lower half of the atmosphere is expanding through a process known as thermal dilation. It's essentially because warmer air takes up more volume. Those air molecules are bouncing around more and more energetically, as if you heated up a container, a closed container, kept the lid on. That lid might want to burst off. Same process. But that air then is starting, it's expanding. It means you have to go higher up into the atmosphere to achieve that half mass layer, because the mass in the lower levels is less because the density is lower. That air is expanding. But we still have the same amount of mass overall in the atmosphere. So what it means is, again, we're just moving that layer to a higher level of the atmosphere. So the 500 millibar, what is known as the geopotential height level, is increasing. So how high you have to go in the atmosphere to get to the half mass layer is getting higher and higher over time. And it's doing so in ways that are spatially non-uniform. So the places where the lower part of the atmosphere is warming faster than others is where we see those geopotential heights rising faster than in other places. And it is the relativeness of this geopotential height pattern that dictates ridginess, if you will, or trophiness, this property of the 500 of the geopotential height field to be wavy. Long story short, the fact that we're seeing this record-breaking geopotential height value off the West Coast right now is mainly a function of the fact that the whole lower half of the atmosphere is higher than it's ever been before, because it's warmer than it's been before in modern recorded history. That is really what I wanted to get to with that slightly long tangent there. But it's a good question. And in that sense, yes, we will constantly, for the rest of our lives probably, be setting new and greater 500 millibar geopotential height records. That matters because it affects how hot it is beneath that level and how hot it can become below that level. So it has very tangible effects. It also affects how dry the surface levels can be during heat waves, therefore how extreme droughts can get, how extreme wildfires can become. But if we want to know about storm tracks and precipitation, the absolute value of that 500 millibar height field matters less than the relative ridginess values, so the spatial gradients. And that is then a question that is more like the question of high and low pressure systems changing generally. There has to be ridges and troughs. So even if the geopotential height field expands everywhere, there will still be some places where it expands more than others, And that is a key question that is not fully answered. So, in a certain sense, yes, we will see stronger ridges and stronger quote-unquote heat domes because the atmosphere is getting warmer and thicker and the 500 millibar layer is getting higher and higher. But will we see more relative ridginess in a place like California is, in fact, a different question. In autumn, the answer may be yes, but the answer in winter and the rest of the year is actually less clear. All right, I'm just scrolling through some of these questions. Some temperature reports. A lot of temperature reports. Okay, so we're getting late in the hour, so I do want to shift to Helene. For folks who joined me for the last doubleheader live session, right, this past weekend, discussing sort of the early aftermath of this devastating major hurricane landfall, but perhaps much more significantly, this truly incredible and horrifying rain event in the Southern Appalachians. The images that have emerged of the devastation are really pretty horrifying, and unfortunately the images that have yet to emerge are actually the scarier thing in all of this, because we have not seen images still, even days later, from the hardest hit areas. There are still people who have not been able to reestablish communication with the outside world. So the larger towns and smaller cities like Asheville, at least there is one road now open into Asheville, although the power is still out. There's no potable water, and there's a lot of folks still at direct risk there with patchy telecommunications. But outside of the larger towns, it's still kind of, people have described it, including one person who texted me directly, as the sort of a scene of The Walking Dead. And some of the images that have just started to come out in the past couple hours do support that pretty directly. If anybody watched the first season of The Walking Dead, which was not incidentally, it was filmed in Georgia, not far from where a lot of this is unfolding, the images are kind of eerily reminiscent of that. That's the level of damage and sudden disconnectedness from the rest of society I think that folks in Southern Appalachia are experiencing right now. And the reason why this happened, it was really a 1-2 meteorological punch. The first was a historic rain event that preceded Hurricane Helene, but was related to it. It's what's known as a predecessor rain event, and it's when a big blob of tropical moisture and instability gets ingested by an upstream storm system or a cold front, which wrung out a record-breaking amount of rainfall over the Southern Appalachians late last week. And then Hurricane Helene, an unusually strong and fast-moving Category 4 at landfall hurricane that maintained hurricane strength all the way up toward about Augusta, Georgia, so well inland, as it made a beeline for western North Carolina and eastern Tennessee, then ended up producing a second record-breaking rain event in a row. So one day, record-breaking rainfall, and then the next day, in its own right, a record-breaking rain event. So for the 2-day period, or the 3-day period, pretty extraordinary amount of water that fell. So for perspective, in a 2 to 3 day period, so let's just call it a 3-day period to be inclusive, there were most places in the Southern Appalachian Mountains of western North Carolina and eastern Tennessee saw over 20 inches of rainfall. In some places, it was actually over 30 inches in 3 days. So on average, 10 inches per day every day for 3 days. And there were a few credible reports of rain totals as high as 36 or 38 inches, again, in that 3-day period. Now, part of the problem is this event was so destructive that all weather stations lost electrical power, and most of the cooperative observers either had to self-evacuate or in some cases haven't been heard from, as I'm hearing. So that's that's kind of a grim statement about the state of things. So it is actually possible that there are even higher values that we're missing because it was so bad that the report wasn't able to make it out, at least not yet. But we know for sure that rain as high as 30 inches in 3 days occurred. Now, we've seen that before in other parts of the southeast. So we've seen that in eastern North Carolina, and even higher values, closer to 40 inches. Hurricane Harvey, or Tropical Storm Harvey at the time near Houston, over the course of 4 or 5 days dropped up to 60 inches, 60 inches, just an incredible amount. But here's the difference. All of those places are relatively flat. When Florida gets 30 inches of rain from a tropical cyclone, from a hurricane, from a tropical system, the problem there is that it's pretty flat and that water tends to stick around, but at least the water that's there it rises relatively gradually. This was by no means a gradual flood event in the Southern Appalachians because, of course, you're in the mountains, and all of these watersheds are pretty steep. In fact, there are quite steep hill slopes, and a lot of the populated parts of this region are in the river valleys. These are alluvial valleys, carved literally by the rivers themselves over millennia. The problem is that when you get a really extreme rain event like this, those rivers can carve a new path, and the river doesn't really care what is in the path that it wants to take. And we've developed these floodplains. Cities in general are developed in floodplains partly because they're desirable and because they're relatively flat compared to the surrounding area. It's easier to build there. It's desirable to be along a river. It used to be the case that rivers were important sources of transportation, so this is historically why there's a lot of stuff in the way in floodplains and near rivers. But that becomes a really big problem when you're in a steep mountainous area that gets 20 to 30 inches of rain in 3 days. And to be clear, this was the largest amount of rain ever observed in this region, exceeding even the Great Flood of 1916, which is somewhat analogous to the Great Flood of 1862 in California. So this event exceeded the Southern Appalachian equivalent of the Great Flood of 1862. It was sort of the historical benchmark that had not really come close to being exceeded since then, and they just kind of obliterated it with this event, despite modern flood defenses, despite ostensibly major infrastructure improvements. And so this was a pretty shocking event, but perhaps not a surprising one. And this is something that's interesting, is that there had been many stories in recent years about how Asheville and other parts of the Southern Appalachians were a quote-unquote climate change haven. These kinds of stories always strike me as odd, if not outright misleading, because it's quite clear. We know, even if you just look back at history to 1916, for example, this is a region susceptible to extreme floods. We know that extreme floods and extreme precipitation is becoming more likely in a warming climate. So even though it is perhaps comfortable much of the time with relatively few major snowstorms and relatively few major heat waves, it's a place that's intrinsically at risk of extreme floods, and that should have been pretty obvious. But I think we often, in these conversations about mean climate change, we forget about the extremes. And even ignoring climate change for a moment, we often think about a region's average climate. And this is particularly true in places like California, actually, which is where I wanted to go with this. There's a reason why we've developed the arc storm scenario for California, and this is what we've talked about. The hypothetical but very plausible multi-week extreme storm sequence composed of a long series of extreme atmospheric rivers that would produce catastrophic flooding in California. We know similar sequences have happened. It happened in 1862. It's happened about every 150 to 200 years according to the geological or paleoclimate record. We've just gotten lucky in the past century or so that it hasn't happened, and with the warming climate, we're upping the odds. We have research that shows this too. One of the things that has been hard to see, as somebody who has been directly involved in developing this arc storm scenario for California, is that essentially the Appalachians just experienced an arc storm level event. This is what we would expect an arc storm level flood scenario in California to look like in the real world on the ground, with even major urban areas being, in some cases, devastated with major direct structural damage, most lines of transportation, telecommunication, water, and electricity simultaneously being cut, potentially for days or weeks, and in some cases even longer than that. That is what folks are facing now in the Southern Appalachians, and this is also what big chunks of California would face in an arc storm-like scenario. except that in California it would arguably be on an even larger scale, because there are parts of California that are similarly flood vulnerable as the Southern Appalachians, but are home to 10 times more people. So the population density in the places in California that would experience this level of damage is a lot higher. So the populations at risk are much higher. So I think that really is a little bit sobering for those of us who've been involved in this project to see an arc storm level event in terms of extremity, in terms of societal impacts, and in a place that has complex topography. Obviously, the Southern Appalachians, the geography is different than California, but the thing that's shared is there are some pretty significant mountains and some pretty significant flashy rivers along populated areas that run through them, along with, in California, the added bonus of having millions of people living in the floodplains, the broader floodplains below, not only in the San Joaquin and Sacramento valleys, where there are cities with millions of people in them, but even places like the Los Angeles County coastal plain, which is literally much of the city of LA is encompassed within that. So I think it's sobering from that perspective, but also to see just how overwhelming a disaster this has been. There are still places, unfortunately, that search and rescue teams have not reached since Friday. It's late on Tuesday. It's starting to get to be kind of a long time for that still to be the case. And this is not because there's been any delay in response. By all accounts, the governor of North Carolina, and the federal government have coordinated well, and they both agree on this point. The governor of North Carolina and the local city mayors and county managers in this region have all suggested that they've gotten all the help they asked for and more. The problem is it's just that bad. In some counties, there are no roads left. There are no power lines left. There are no water lines left. We're not talking about flooding. We're talking about highly destructive, high-velocity debris flows and water that have pretty much carved new canyons, new river paths in some places. So this is not a matter of waiting for the floodwaters to recede or taking a bulldozer or a grader and pushing the mud off the road. In some places, of course, that's what's happening. But in other places, the roads are gone. And they're realizing in the place like Asheville, for example, this is a city of 100,000 people that has no water indefinitely now. They think they may have to rebuild the entire water sewage treatment system from scratch. There's almost nothing left. Same thing with the power grid. These aren't just power lines that came down or poles that came down, but the substations are wrecked. They're going to have to be completely replaced. This is not equipment that is easily sourced or installed. So I think this is a bit of a microcosm. It is, again, arc storm-like impacts affecting hundreds of thousands of people in the southeast. The difference is if and when this happened in California, it would be similar impacts, but for millions of people. And so I think it still hasn't quite sunk in just how bad things are in Southern Appalachia. I think the news is finally getting out, but I think in the initial hours there was an assumption that no news is good news. And we know in California, from recent wildfire catastrophes, that that's just not true. Some of the initial reports out of Paradise in 2018 were that, well, we haven't seen images of the town burning, so it's probably okay. But of course, those of us who knew what was really going on at the time were quite acutely and painfully aware that was not the case. And this is a similar situation, I think. There is this reality that it's difficult to get the media in. It's difficult to get images out because the cell networks are down, and there are just a lot of places that are very difficult to get in or out of. And so right now, the death toll, it is in the triple digits, the low triple digits for now, but it likely is going to rise. There's up to 1,000 people still missing, and we've heard that before. We heard that with the Lahaina fires on Maui. We heard that in any number of California wildfires where there were initially thousands of people missing, and of course the death toll was at least an order of magnitude lower than that. But these are still large numbers, and it's likely to rise quite a bit. So we'll probably end up being one of the deadliest, if not the deadliest, inland flood events. I unfortunately have to separate this from events like Hurricane Katrina in the United States, and also Hurricane Maria in Puerto Rico, both of which had death tolls in the thousands in recent years. Of course, both in the U.S., but those are both regions that are within 50 or no more than 100 miles from the coast. And in this case, this truly is a different kind of event from a meteorological and geographic perspective. We have not seen something on this scale in a long, long time in North America. We have seen other events like this, though, this summer in other parts of the world, including in Central Europe. There was an arc storm level flood there in parts of Austria, the Czech Republic, just a few weeks back. And in the Sahel in northern Africa with extremely heavy rainfall. One of the downsides of the greening of the Sahel that we've talked about is this reality that there have been major floods there that have killed thousands of people. So even as Hurricane Helene was unfolding, in fact, there was a devastating flood event unfolding on the tropical west coast of Mexico in Acapulco as a result of a stalled Hurricane John there, which is the second year in a row that part of the Mexican coast has been devastated by an anomalous tropical rain and wind event. So the point is that I wish this were a completely out of the blue, isolated anomalous event. It was very well predicted by the Weather Service. In the days leading up to the event, there was language like catastrophic flash flooding expected that you've never seen in your lifetime and probably hasn't occurred in the last 100 years. That's about as strong of language as you could possibly get from the Weather Service. So the weather predictions were very good, but I think the preparedness was really challenging. That is one of the reasons why we do what we do with things like Arc Storm. And I have a bunch of threads that have gone more viral than anything else I've done in years. Far more people will read these than will ever read my scientific papers, but you can go on Twitter or on Blue Sky or Threads or Mastodon, whatever your favorite platform is. They're all on all of them. I'm now cross-posting across all of them. But if you want to read my deeper thoughts on this, on why we do need to talk about plausible worst-case scenarios and why I don't think it's pessimistic or depressing to do so. I think it's absolutely vital and necessary, and I actually view it instead as essentially as my version of being optimistic about the future. And the reason for that is because we need to be honest about the big bad things that can happen if we want to either avert them, prevent them from happening in the first place, or at least when they do occur, make the outcomes less bad. I actually think that's a very positive way to think about the future, in the sense that even when the worst happens, it doesn't have to be as bad as it could have been. And if we're lucky, maybe we can avert it entirely in the first place. But we can't do either of those things unless we're honest about the kinds of risks that are all around us. And I think that there is a real sense right now that it's very important to be a climate optimist. And I think it is important to be optimistic about our ability to bend the carbon curve and reduce the burden of these growing and outsized extreme climate impacts all around the world. But I also think in that same moment it's critically important to sort of be circumspect about the kinds of big bad things that are possible today and that might happen tomorrow, and how that range of what is plausible is, first of all, probably wider than most people were willing to recognize, even absent climate change. So even 100 years ago, we were a little bit naive in that sense. We should know better today, but sometimes we still act as if we don't. But that the range of what is plausible on the extreme climate spectrum is, in fact, widening. And the worst case scenarios are actually getting worse for events like Helene. In fact, some of the early attribution studies, and this hasn't been widely circulated yet, but there's some preprints that are already out, believe it or not, on the event that occurred less than a week ago. And they suggest that climate change may have made the rainfall during this extreme event as much as 20 to 50% worse than it would have been. Even I am surprised by how large those numbers are. And we'll see what the lower bound on that actually is. These are preliminary numbers and they might be adjusted. I would have been comfortable saying that it's highly likely that the extreme rainfall during Helene was anywhere from about 15 to 25% worse, just based off of very rough back of the envelope calculations. But even if that's the case, that's still an enormous increase. What's 15 to 25% of 30 inches of rain? It's a very large absolute difference, is what I'm saying, and outcomes would have been different. There was a time where there were a bunch of flash flood emergencies issued by the National Weather Service during this event for portions of western North Carolina and eastern Tennessee, because it was thought by entities up to and including the Tennessee Valley Authority that critical and major, what are known as high hazard dams, might fail entirely. They might literally collapse because this was an event beyond design standards. And there was observed evidence of water overtopping dams and undercutting dams. So there was a real risk at one point that we could have lost 3 or 4 major dams in the U.S. that would have made this already catastrophic event just on a whole nother level. There probably would have been deaths on the order of thousands, to be quite honest, had that happened. Fortunately, it didn't. And it turned out that none of those dams actually failed, although many of them were significantly damaged, and we did come awfully close to the brink. But here's my supposition. Here's my question, actually, for the audience at large. Okay, well, let's just imagine for a moment conservatively that climate change did make the rainfall during this event 20% greater than it otherwise would have been. What if 20, 30 years down the line, with our additional global warming, an equivalent event at that point was another 20% higher? Would the dams still have held then? It's not so clear that they would have. And so I think this is a good example, a tragic example and a pretty dramatic one, of why each 5 or 10% here and there matters, because we have a lot of thresholds built into these systems. A dam literally has a visible, tangible threshold. There is a water level at which water overtops the dam or it does not, or undercuts the dam structure or it doesn't. We experienced this in California during the Oroville Dam crisis. And again, to remind folks, it's widely believed that climate change made the inflow to Oroville Dam during that crisis 20 to 25% greater than it would have been 50 or 60 years ago during a similar event. We came very close to the brink there too, but just short of it. Fortunately, the crisis did not become a catastrophe in that case. But once again, what if we were 10, 20, 30 years down the line and there had been an additional 10, 15, 20% of inflow into Oroville Dam during the 2017 crisis? Would we have tipped over from a crisis to a catastrophe? It's very plausible that we could have, based on what transpired. Now again, hopefully that particular dam spillway has been improved. The emergency spillway has been improved as well. Hopefully that particular example won't be so relevant in 30 years because we've mitigated some of the risks. But my point is, these risks exist everywhere. There are built-in thresholds that are sensitive. The first 5, 10, 15, even 20% increase, maybe our systems can handle it. Maybe 21%, 22% is the percent that broke the camel's back. And so, obviously, this is not just a question of climate change. There's all sorts of things going on in these systems. There are more people living in floodplains than ever before. We have outdated and crumbling infrastructure in many cases. But, there is also the reality that this event was more extreme than it would have been in a cooler climate, and that similar events in a couple decades from now will be notably more intense than they are today. And what we're seeing is that these systems are starting to get to the breaking point. This is an example of a region that unfortunately has experienced a region-wide crisis where virtually all systems and infrastructures have ceased to function as a result of a substantially climate change amplified disaster. I think that's a pretty defensible statement at this point. There are probably people who died in this event who would not have died had the event been 20% less extreme. And, a lot of folks really don't want to talk about this in the moment of disaster. This has been the kind of criticism that's come up during any number of California wildfires or extreme heat events. And it is true that the most important thing is getting assistance to the folks who are directly affected by this. And that is, in fact, exactly what's happening. There's an all-hands-on-deck effort to do this by the federal government, the state government, and in fact, there are search and rescue and swift water rescue teams from, I believe it was about 20 different states, including California, that have already been on the ground in North Carolina and Tennessee for a couple of days. So the problem is not that there is no one coming to the rescue. There's a huge army of folks who are either there or en route already and have been. So I don't think that having this conversation detracts from that at this point. And, it's not, I think, opportunistic. It is necessary to talk about the multifactorial realities when we're experiencing disaster, because this is when people are paying attention to it. This will sadly be largely out of the news cycle in a couple of weeks, even though the recovery by some experts is expected to take up to 20 years in western North Carolina. Some places will probably never look the same that they did before this event. And yet, there may be a smattering of stories in, at the end of the year-end summaries, early next year, but this will largely, outside of the region itself, be forgotten. And so that's an interesting statement, perhaps, about the world we're living in right now. But it's also really an articulation of why it is so important to talk about these things while the event is top of mind. There is a lot of interest right now in what the heck happened and how the heck it could have gotten so bad. And that is an important part of the story. It certainly isn't the only part of the story. But I think that, we can walk and chew gum, as it were. We can have both of these conversations at once. We can acknowledge that the most important thing is the immediate disaster relief. It's initially the search and rescue. It's initially the provision of emergency water and food and telecommunication infrastructure. And in the long run, it's providing long-term recovery, which it's a whole different story than the short-term issues. But we can also talk about why this happened. Why was it so bad? Why are we so bad at visualizing and preparing for plausible worst-case scenarios? And why is it so important that we do so? Because it's not a pleasant conversation, but it's a critically important one. And, as I mentioned in some of these threads that have, taken off the last few days, I view this as the most important piece of my job today as a extreme weather and climate scientist who's, quite frankly, rather visible in the public eye, because I have a sort of a platform to force those conversations even when people don't want to have them, which is a privilege. It also makes me fairly unpopular in certain circles, but I think it is. I'm not going to stop doing it because I think it's the conversation that we need to have. So, with that, just to summarize, this is an R-storm level event. What has unfolded in the Southern Appalachians, particularly in western North Carolina and eastern Tennessee, although also some adjacent portions of northeastern Georgia and the far western South Carolina as well. There are hundreds of thousands of people who are in dire straits, and there are hundreds, if not a couple thousand people who are still missing, most of whom hopefully will end up being okay, but just stranded somewhere without cell phone access. But the unfortunate reality is the death toll will probably be in the hundreds. So this will be one of the deadliest inland flood events in modern U.S. history, on par with the level of impacts we saw with Katrina or Hurricane Harvey, but in a mountainous area that's much more remote than either of those places were. And I think there's some lessons for California in that this, again, we have war gamed this out, if you will, for a similarly extreme event in California, except that if and when, really it's a question of when rather than if it happens in California, it probably won't be as a result of a hurricane. It'll most likely be a result as a sequence of powerful winter atmospheric river storms. But, it'll affect even more people. And I think this is a conversation that we're finally starting to get some traction, within the state of California. But I still get emails from engineers and people who are involved with water management in California that Arcstorm is a completely ridiculous scenario. Could never happen here. Well, I'm telling you right now that it can happen here, and that's not even a very bold statement for me to be making, because it's happened here over and over and over and over again in the paleoclimate record. So it's really a question of, are you feeling lucky? How much do you want to gamble that it's not going to happen on your watch? It's a riskier gamble with each passing fraction of a degree of warming. I will tell you that much. So whatever the risks were 100 years ago, they're higher now, and they're going to be higher in 30 years. So for California, I think that's another lesson here. So I'm well past the hour now, but I did want to have this conversation about Helene, and I will take just 3 or 4 minutes now to quickly look at the questions, since I know I'm impressed that this many folks have stayed on, since this is now not just an office hour, but we're veering into office hours, plural, and I do need to give my voice a rest soon, but let me just take a quick sip of water and take a look at the questions. I will pick and choose a few of them to answer right now. Well, I think I answered the first question from Lori pretty directly just now. Yes, atmospheric rivers are very likely to become more intense, and that is the main reason why we think that the risk of an arc storm level flood event is increasing, and in fact has probably already increased in the background in an era where we've been more concerned with drought and wildfire in this part of the world. Elizabeth asks, were folks advised to evacuate? Did NOAA issue a warning? This is a very interesting thing because these are two very different questions. The answer to the second question is absolutely yes. The Weather Service and NOAA's different agencies tasked with, specifically with extreme precipitation prediction, did a phenomenal job with this and highlighted again, the language leading up to this event was expect catastrophic, widespread flash flooding exceeding anything in lived memory and possibly even approaching or exceeding levels of the flood of record in 1916. I don't know how much better a forecast realistically you could get than that. And that's also pretty clear messaging. That's not just saying, heavy rain and flood possible. The warning was specifically catastrophic flash flooding likely, worse than anything you've ever seen and possibly worse than anything in a century. There is a point at which there's only so much you can do on that front. But I don't think we've reached that point because the answer to the other question was not so much. There were not a lot. There really weren't preemptive evacuations issued in most cases. So I think that's going to be an important question in the aftermath. Despite that warning and the flood watches and the messaging from the Weather Service and from NOAA in the days leading up to it, and this really strong warning and forecast, and local meteorologists did the same thing. You turn on the Weather Channel and they were highlighting this too, so this was no mystery. Very well predicted. But a lot of folks were still taken by surprise. So there's still a failure there somewhere. Local officials were taken by surprise, and that is the failure I think is unacceptable. On some level, you can only convince people to listen to the Weather Channel or Weather Radio or go to weather.gov so much, right? But you really should be able to more strongly motivate local governments and local authorities to take preemptive action. And I think that's maybe where there was a bigger gap that hopefully can be a lesson learned, and hopefully can be a lesson for California too, because that is where the rubber is going to hit the road with these early warning for these events. We have pretty good predictions when it's going to get really bad. So you shouldn't really wake up one morning and find the water coming through your front door, even though that is apparently what literally happened to thousands of people in Appalachia with this event. The forecasts were great, and yet that still happened. So where's the gap is the interesting question. And that is, again, one of the reasons why it's so important to do these exercises that nobody wants to hear about. Everyone just, stick your fingers in your ears and say, la, 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 I can't hear you. That is literally the response, that we've gotten to Arc Storm in some circles. Less so today than in previous years, but still, it is not an uncommon response. And this is why it is so important that that not be the response moving forward. Charles mentions that 3 generations is the relative limit of social memory. I have colleagues who've studied that our current social media era memory is actually only about 5 years. There is literally, I have a colleague at UC Davis, Frances Moore. She did work using Twitter data back when that was more accessible, showing that the declining remarkableness of extreme heat. Essentially, people don't perceive record-breaking heat to be record-breaking anymore unless it exceeds something that's happened in the last 5 years. So that's a pretty dramatic iteration of shifting baseline syndrome. I don't think we have a collective memory really going back 3 generations anymore at all. I think it's going back 3 to 5 years, perhaps, which is arguably part of the problem. Yeah, Mary makes a good point that one problem that North Carolina is not facing so much is that the floods move through violently and with great force, but then we're done, mostly, because it's fairly steep terrain and the water's draining elsewhere. It's someone else's problem now. In California, the same thing would happen in the mountains. So, of course, the western slopes of the Sierra Nevada, the transverse ranges of Southern California, an equivalently severe event, you'd see this initial extreme flash flooding, and then, or waves, perhaps, of flash flooding in a multi-week arc storm event. But then the flooding would recede there. But then we got a whole new problem in California, which would be the Central Valley. because the San Joaquin and Sacramento rivers are integrating flows. It takes them longer to respond to the extreme precipitation. And there, the floods could linger and accumulate, especially if there are major levee breaks for months, in places like Tulare Lake for years thereafter. And it might not be only Tulare Lake that would see years-long inundations following an arc storm level event. So that's an interesting question. We still haven't gotten the funding to finish the modeling for that, so we don't know exactly what that would look like in terms of inundation because, again, this has been a very hard sell. It's difficult still, even now, to talk about these kinds of things, even in a place like California, to be quite honest. Yeah, Mary mentions the friend of hers is in Asheville, says there's no water or electricity and they're almost out of backup drinking water. Well, it's one reminder that it is really important to have that backup drinking water. Imagine what it would be like if you didn't have any to start with. But yeah, I mean, this is the thing. Like, even people who were really prepared and had like 3 to 5 day water and food supplies are starting to run out in some of these places, even in larger towns. So again, that just speaks to, I think, to the scope of this. Mark asks, before Helene, I'd not heard of a pre-PRE event, meaning a predecessor rain event that I mentioned earlier, which is sort of what the first half of this extreme rain and flood event was. Are these only associated with tropical storms interacting with existing low pressure areas? Essentially, yes. This is a fairly unique thing. It's not something I think that we would ever be particularly likely to see in California, although I suppose never say never in the sense that you could get a somewhat similar event in the sense maybe of an autumn tropical cyclone interacting with an early season Pacific storm. The difference is hurricanes really like to fall apart when they get anywhere near California because the ocean's too cold. So you do have that benefit, but in a really extreme outlier scenario, maybe you could see something somewhat analogous. But it's a far more common on east coasts of continents and your western warm boundary currents. Yeah, Mary mentions we do plausible worst case scenarios with earthquakes. I actually think we do a much better job thinking about plausible worst case scenario earthquakes in California than we do worst case scenario weather and climate events. In fact, a lot of the people I've been working with on ArcStorm are with the U.S. Geological Survey, who were directly responsible for California's very progressive stance on catastrophic earthquake risk and the fact that California is, despite its continued vulnerabilities, far better prepared, both in terms of engineering design standards and in retrofits and emergency preparedness for a huge earthquake in, say, LA or San Francisco, which will happen eventually, than it was 30, 40 years ago, largely because of the efforts, I would say, of these particular people. So, it's the same idea, really, but for some reason, it just seems to be a much harder sell for extreme floods. People just don't want to think about it in California. All right, I'm almost done making it through the comments here. Okay, just a reminder to folks, since there were a couple of people who got upset that I didn't answer their questions today. I have never had a single session where I've had time to get to every person's questions. So sometimes I have to be selective. There are a variety of reasons why I don't answer everyone's questions every time. Usually it's because there's a particular focal topic of the day, as there was today. I do have occasional Ask Me Anything sessions, and then anything within reason is fair game. But mostly it's just because we're at the 90-minute mark of my originally scheduled 60-minute session. So sorry I couldn't get to all of them. What I would encourage folks to do, though, is to join me on the less dramatic weather days, because those sessions tend to be less well attended, and I'm able to answer a larger fraction of the questions that come in on those days. So as always, thank you for your support and engagement. And it is helpful if you like these videos, especially if you want to be notified when I do these live sessions. Subscribe to the channel. And with that, I am going to give my voice a break, and I will see you all next time. Thanks for joining.